Okay, good morning. So we continue the lesson. I just want to complete what is left from this chapter. So it might be there are different titles. Uh, I chose this title, probably it's not that appropriate, so more on tangent lines. So let us start with the original problem so that I can refresh your memory a little bit and then start the new lesson. So example, determine, this is a typical problem, so determine an equation determine an equation for the line that is tangent to the graph of the function f of x is equal to 2e to the power of 3x plus 3e to the power of minus x plus 2 at the point on the graph So here, because the lesson will be about this, I want to emphasize the point on the graph. So of course, this is the only problem we were able to solve till now, but because the next lesson, more on tangent lines, is about that what happens if the point is outside, let me emphasize this phrase today. So point on the graph whose x coordinate is ln of 2. So the structure of the problem is exactly what we know from very early lessons on derivative, but I change the format a little bit because in the beginning we didn't know about the derivative of exponential functions. Today we know, and I mix it a little bit with ln so that make it a little bit more interesting. So, but the idea is the same. The thing that you have to do, you have to remember we have this formula. If this is the typical picture that you should have in mind, yes? So if I have a function whose graph we know, for example, y is equal to f of x, and then we know a point on the graph whose x coordinate is a, my goal is to find an equation for this tangent line here. Of course, tangent line will continue forever from both sides. If I want to find an equation for this, I need a point, which of course I have it, because the function is given, this x coordinate of the point of tangency is given. You put this number here, you find the y coordinate. So if I call this t, you already know that t is a and f of a. So you do not have any problems with the coordinate of the point. But you need to also know the slope of the tangent line, and that is the actually motivation behind the derivative, if you remember. So what is the k value? The slope of the tangent line is the derivative of the function, but calculated at the x coordinate of the point of tangency. And then when you have both of them, the equation that we had is this one. Do you remember? It was y minus y node. Y node is the y coordinate, which is f of a, is equal to the k value which is f prime of a, times x minus x node, which is a. So do you remember? So that was the idea we had so far. So that's a very, very important, very simple, and very important part of this lesson in this chapter. So any questions regarding that? Okay, so now what is happening here? First, I need to find the point of tangency. The x-coordinate is given to me, so this ln of 2 here is playing the role of this a. Yes, so a in this problem is ln of 2. F of a, what is f of a? F of a is f of ln of 2. So what does it mean? It means that I have to go to my function. I replace the input x with this new value. So it becomes 2 e to the power of 3 ln of 2 plus 3 e to the power of minus ln of 2 and then plus 2. This is my f of a. But this can be simplified. So how can I simplify that? Do you have any suggestions? I don't want, because in the exam I can ask you to find the exact value. So you cannot use your calculator. So you have to be able to simplify this. Do you have any suggestions? How can I start simplifying this? Yes?
Since we have 2 times e to the power of 3 times ln of 2, we can simplify to 2 times 2 to the power of 3, because ln is just log of 2 with base e.
Yes, so if you want to do that, you can put this 3 on top here. So what happens? It becomes ln of 8. Yes? And then plus. This minus is minus 1. I can put it on top here. So what happens? It becomes ln of 2 to the power of minus 1. But 2 to the power of minus 1 is 1 over 2. So if you want, I can write it here for you. So this expression is minus 1 times ln of 2. And you know that if you have a number here, we can put it on top. So this becomes ln of 2 to the power of minus 1. But a better name for 2 to the power minus 1 is 1/2. So this becomes ln of 1/2. Yes? And then I have 2 at the end. But we have a formula, yes? Do you remember? The formula, as Simon mentioned, actually is e to power ln of a. What's the answer? E to power ln of a is a. So e to power ln of 8 is nothing except 8. But I have a 2 here. Plus, exactly for the same reason, this becomes what? I made a mistake here. Sorry, this is 3. I forgot to put e here. I forgot to put that e here. Okay, and then e to power ln of 1/2, exactly with the same formula, the answer becomes 1/2. So 3 times 1/2 plus 2. And then I simplify this, so it becomes 16 plus 3 over 2 plus 2. If you take the common denominator, 16 plus 2 is 18. By this common denominator, it becomes 36. And then plus 3. So this becomes 39 over 2. Okay, so what happens? A was given to me from the beginning. I myself managed to find f of a. F of a becomes 39 over 2. Yes, do you agree with me? Okay, so this is also important because in the exam or in the national exam I have seen, they might give you an expression like this only and ask you to simplify that. So I'm just giving one problem to birds with one stone. So we are also refreshing our memory about this idea. In the meanwhile, we're also learning how to simplify expressions like this. Okay, so we have this one. So the last thing, so f of a, I know. A, I know. So the only thing that is missing for me right now is f prime of a. So I start calculating the derivative of the function. So f prime of x is equal to what? F prime of x is equal. Hopefully you remember how to differentiate the function. This 3 goes down, so it becomes 6, but the function repeats itself. I'm using this formula, e to power kx. Derivative is k e to power kx. This we had before, yes? So then the same story here. K here is -1. -1 goes down, and the function repeats itself, but the derivative of 2 is 0. So this is f prime of x. But to calculate f prime of a, so what should I do? F prime of a, what is a? A is ln of 2. So this becomes f prime of ln of 2. And more or less the same story. I have to repeat it here again, the same method. Yes? So f prime of ln of 2, it means that I have to go to my derivative and replace the input with this new input. So this becomes 6 e to the power of 3 ln of 2 minus 3 e to the power of minus ln of 2. But that is more or less the same problem. So let us just do it a little bit faster. So this becomes e to the power, I put this on top here, so this becomes 6 e to the power of ln of 8. And for the same reason, this becomes 3 ln of 1 over 2. Exactly as my explanation there, but e to power ln of 8 is 8. 8 times 6 is 48. E to power ln of 1/2 is 1/2. Multiplied there is minus 3 over 2. And then if you simplify that, it becomes 96, 93 over 2. Yes? So what happens is that my f prime of a is also found. It's 93 over 2. You need to know this problem very good. The structure of the problem is the same. The only thing that I can change the function, I can change this number, but the structure of the problem remains the same. Okay? And now everything is ready, you put them in this formula. So what happens? This becomes y minus f of a is 39 over 2. F prime of a is 93 over 2 times x minus ln of 2. So that is what we want. Usually it is common to put y, to isolate y. In that case, you can move this to the other side. So what you can write y is equal, I multiply this in, but I want you to keep the exact value, so you don't need to touch it, and then you move this to the other side. Yes, so this is the answer. Yes.
Could you factor 1 over 2 out of that?
Yeah, you can do that, whatever you liked. Okay, so that is more or less what we had so far. But now today I want to change it a little bit. What happens if I have if a point outside the curve is given, and you are supposed to draw a tangent line from that point outside the curve to the curve? I want first of all think about why the problem is a new problem. Okay, so what do I mean by that? So let me just draw some picture here for you to save some place. So the problem is different from this picture a little bit. So here I assume that this is my graph, but I choose a point that does not lie on the graph, say this point, and I give you the coordinates of this point. For example, I give you, this is alpha and beta. Assume that I give you alpha, I give you beta, and I give you the function. It is very easy to check that this point does not lie on the graph, because you put the numbers there, you see that it doesn't work, you realize that this point does not lie on the graph. Now the question is that in this picture, it is sensible to realize that I can still draw a tangent line from here to the curve. Yes? But the question is that now I want to find an equation for this tangent line. Now, first of all, tell me why the problem is different from that problem. So for example, because I want to write the equation of the tangent line, I still can use that formula, yes? This is what you learned in Math 2C. If you know any point with coordinates x node and y node on the curve, on the line, and k value of your line, you can put them in this formula and find the equation. In this case, can you tell me what I can put for x node and y node? Alpha and beta, because it doesn't matter which point is that. So I do not have any problems with these two. Again, my problem is with k. But why finding k in this problem is different from finding k in that problem? Yes, Rasmus?
Because in the first problem, we could easily find k, the k value, because we had an x coordinates to plug into a derivative for that. But we have no idea where the where the tangent line lies on the curve.
Exactly. Because I mean, might be I didn't mention it explicitly today, but it is extremely important when you want to find the k value. You find the derivative, but you have to put the x coordinate of the point of tangency to find k, not any point, okay? So let me emphasize today here that this a that you put here is the x coordinate of the point of tangency. Yes? So it's very important that if you want to find the k value, you can calculate the derivative, but what you have to put inside your derivative is only this, the x coordinate of the point of tangency. And in this problem, I do not have the point of tangency, because what is given to me is the equation for this curve and the coordinates of a point outside the curve. I want to draw this tangent myself, and I do not have any control on where this point is. So first of all, I just want you to understand. Do you understand that this problem is now different? Okay? Because if I want to calculate this k, what I have to do, I have to take the derivative. So I just want to emphasize that f prime of alpha is not k, because alpha is not the x-coordinate of the point of tangency. So that's the problem. And I think the best way to do this is to start with an example, okay? So this is the new lesson now. Example. Determine an equation for the tangent line, and I put S here because sometimes if the point is outside, you might be able to draw more than one tangent, yes? For example, if you, this the very famous one is the circle. If I give you a point here, you can draw this tangent, you can draw that tangent, yes? So we don't know how many tangents are there, so this is why I put it in pair brackets. Determine an equation for the tangent line or lines that one can draw from the origin to the curve of the function. Let me make it simple, hopefully it will work. The function f of x is equal to x squared plus 1. Yes? So if I want to understand this problem a little bit better, let us sketch the graph to understand it better. Of course, you don't have to, but it doesn't hurt, okay? So the graph of x squared, you know, it's just the famous parabola, but this is 1 unit higher, so it will be shifted 1 unit up. So if I want to understand what's going on, so this is the graph of this function, for example. Okay, and this is the origin. I want to see, of course, how many tangent lines do you expect to have?
2.
Probably 2, yes, if any, yes. So let us, for example, from here, I can draw this tangent line, and of course, because of symmetry, I can do one from here. But let us not confuse ourselves. Let us just understand how can I find this one. Okay, so this point is given to me, is the origin, so I know the coordinates. The coordinates are 0 and 0. But the point is that I do not have the point of tangency. This is the way that I want you to know how to solve it. You pretend you know it. What do I mean? I mean that you put here, point of tangency. You don't know it, but you pretend you know it by, okay, I would say that the x-coordinate of the point of tangency is missing. Let me give it a name A. But still I don't know A. But if the x-coordinate of the point of tangency is A, then I can immediately find the y-coordinate of the point of tangency, what that is? A squared plus 1, yes? Because the point of tangency, by definition, is the point which lies on the tangent line as well as the curve, yes? So it means that if the x-coordinate of the point of tangency, I pretend I know it and it is A, then the y-coordinate is definitely a squared plus 1 in this case, yes? And then solve the problem as before. Okay, what do I mean? So you have this equation. This is the equation for your line. So what is f of a? I know it. F of a is 8 squared plus 1. I told you, I pretend I know it. F prime of a is easy to calculate because from here, I calculate f prime of x, which is 2x, extremely simple. And then f prime of a is just simply 2a. Because f prime is a new function. This is the input. It gives me 2 times the input. Now I put a, so it becomes 2a. I put it here. And then x minus the x-coordinate of the point of tangency. So this is the equation that I'm looking for. But still, I pretended that I know A, but in reality, I really don't know A yet. Okay? Is that understandable so far? But how can I find this A, finally? Because that's the point. How can I find A? Yes?
We know that both sides should be equal to 0.
We know that the origin is supposed to lie on this line.
Yeah.
Yes?
So, we can.
So it means that if I replace x and y with the coordinates of the origin, the equation should be valid. And this will give me one equation in which a is the unknown, so I can find that. So is the logic clear? I will do the calculation. So what I do, if the point is outside, you pretend that you know the point of tangency by giving it a name, a, and put that a into your function to find the y coordinate. And then you start writing the equation of the tangent line as if you know the point of tangency. That was exactly the one that I wrote there. Okay? So when I do that, I will get an equation. But this equation, even though is the general form of this line, it is not complete yet because still this a is missing. I don't know. I just pretended I know it, but I really don't know. I have to find that. And the only information it's given I haven't used yet, and that is the point, that this line is also supposed to contain this point. So this point is on the line. It means that the coordinates of that point will satisfy this equation. So this means that if instead of y, I put the y value here, and instead of x, I put the x value here, this should be valid. And then you see that this is one equation. You are actually, a is the only missing part. I solved the equation. This 0, this becomes minus a squared minus 1. Here it's minus a. I multiply it here, it becomes minus 2a squared. Okay, I move this to the other side, it becomes positive a squared. I move 1 to the other side, it becomes 1. And then what is a? As you expected, you get two answers, plus or minus 1. Okay, so what happens? When I found a, so how should I answer that? I have to put this a back into this equation, because that was the tangent equation. At this stage, I didn't know about the value of a. Now I found a, so I put this back to find the equation of the tangent line. So what happens? So if a is 1, then, so let me give a star here. From star, what I can conclude is that instead of a, I put 1. Let us do it in our head. So it becomes 1 to power 2 plus 1, it is 2. So it is y minus 2. And then it is equal to 2 times a is 1, so it is 2, and x minus 1. And I simplify that. We can do it in our head. So 2x minus 2 and minus 2 are cancelled. So this becomes y is equal to 2x. So this y equals to 2x is that. Okay, what happens if a is equal to minus 1? Okay, y equals to minus 1. Hopefully you realize this will give me the other tangent line. So if I put minus 1 here, minus 1 to power 2 plus 1 is again minus 2. So here it's y minus 2 again. But if I put minus 1 here, it becomes minus 2. And then x minus minus 1, which is positive 1. And if you multiply this in, minus 2 are gone. So y becomes minus 2x. So determine an equation for the tangent lines. Now we understand that there are actually two lines that one can draw from the origin to the curve of the function, this function. These are the equations for those. But another question that I might ask, what are the coordinates of the point of tangency? This is something, a byproduct of what we calculate. So again, the point of tangency is in front of you, and then I have two values for a. So one point of tangency is here when a is equal to 1. Of course, another point of tangency is here. That happens if a is equal to minus 1. So the point of tangency is either, I put 1 here, this becomes 1 and 2, or t is minus 1 and 2. I put minus 1 here, it becomes minus 1, but minus 1 to power 2 plus 1 is again 2. So this is today's lesson. So if I give you a point outside the curve and you're supposed to find the equation of the tangent line, this is the way that you do it. So the only thing that you need to remember, you give the point of tangency a name and pretend you know it. You solve the problem as you did before. The only thing that you need to do after that is to use the coordinates of the given point to find that missing a. And then when you found a, you put it back into this equation, and then you have it. Yes, is that clear? Okay. So this is something I want you to know about. Another thing that we want to talk today is the normal line. So what is the normal line? So you know already that if I give you a straight line, and if I give you a point on that straight line, and if I ask you to draw a line which is perpendicular to this at that point, then of course you know what to do, yes? You need to draw another straight line so that passes through that point, and when you measure this angle, it is 90 degrees. These two lines are perpendicular, yes? Another word that we want to use is the normal. They are normal. Another word is orthogonal, yes? Of course, they are in different contexts, but this word I want you to know. So we can say these lines are normal to each other, one another. So it means that one of them is perpendicular to the other one. For the case of two lines, we use this word only. But here today, I want to define first, what do I mean? Assume that instead of this original line, I give you a curve, and I pick, instead of this point on the line, I pick a point on the curve. And I ask you to draw a perpendicular line, but to the curve. So first of all, I have to define what do I mean by drawing a perpendicular line to a curve. Okay, so I don't know, how do you define that, if you want to define it? Yes?
Probably the perpendicular to the tangent line.
Tangent line at that point. So that is the definition that mathematicians has used. So when you have a curve, and then people say that draw a line normal or perpendicular to this curve at this point, what do they mean? They mean, first, imagine that you draw a tangent line here, and then forget about the curve, don't see the curve anymore, and draw a perpendicular line to this new tangent line at that point. So this is called the tangent line. This is called the normal line. And I think you can already tell me what to do. If I ask you to find an equation of the normal line, I hope that you can see how to solve it, yes? Do you remember anything about the connection? Because if you don't mind, let me write the k value for this one. Let me write k, but equate it with the subscript t for tangent. And let me write this k value, the slope of that, equate it with a small n to denote the normal. So what is the connection between k sub t and k sub n? Yes?
Just k sub n is equal to minus k sub t?
No?
1 over k.
Minus 1 over k, yes? So we know that if two lines, from Mat to C, if two lines are perpendicular, there is a nice connection between these values, yes? So that's the case. Okay, so this means that if I want to find the k value of the normal line, it's just simple, minus 1 over k of t. And you already know how to find the k value of t, yes, kt, because that is the k value for the tangent line. Okay, so that's the problem. And I can give you an example. Is this picture clear? So let me just emphasize. Assume that this point of tangency, assume that this is y equals to f of x, and I give you the x coordinate of this point. You put the x coordinate point here, you get the y coordinate, and then you have this equation, the tangent line is what? Y minus f of a is equal to f prime of a times x minus a. Do you remember? This was the k value. But now the normal line is what? Is y minus f of a still. Here, I also have x minus a, because still this point is on the normal line as well. But what will happen for the k value? The k value is minus 1 over the k value of the tangent line. That was the k value of the tangent line. So this becomes minus 1 over f prime of a. Yes? But I don't want you to memorize the formulas. I want you to understand how to solve the problem. Is that clear? So let me give you an example. I think it is good to, there's a problem here in the book. Let me exactly choose that one. Okay. This is not the word-by-word translation of that problem, but I will use the same function and the same point. Okay, so the question is this. The function is given to you here. So let me write the example. Determine an equation for the tangent line, for the normal line. For the line, let me write it like this. For the line that is normal or perpendicular to the curve of the curve or to the graph of the function. So what is that in the book? It is y equals to f of x is equal to e plus 7 to power x at the point on the graph whose x coordinate is 0. Yeah, in principle, if you want to be there, you have to write it in words, okay? So determine an equation for the line that is normal to the graph of the function f of x equals to e plus 7 to the x at the point on the graph whose x coordinate is 0. That's exactly the problem in the book. So, okay, so help me to do that. What I'm supposed to do? What is a in this problem? Can you tell me? What is a? A is 0. So what I have to calculate is f of a. Okay, sorry. If a is equal to 0, so f of a becomes f of 0 in principle, because a is 0. But what is f of 0? It is e plus 7 to the 0. But 7 to the 0 is just 1, so this becomes e plus 1. And don't use your calculator. You have to keep the exact value. Unless it is explicitly mentioned in the problem, do some approximations. So this is my f of a. So a is known, f of a is known. But I also need the derivative. because of the k values. But this derivative gives me the k value for the tangent. Don't get confused, okay? So f prime of a means f prime of 0 because a is 0. But in order to answer this question, what do I have to do first? I have to calculate the full derivative. I mean the derivative of the function. So do you remember what is the derivative of this function? The derivative of e is what? Yes, 0, because that's a constant. But the derivative of this one we had before. If you remember, we had a to power a to power x. The derivative is the function repeats itself, but that is not the whole story. You have to multiply it by ln of a. So this will of course given to you in the formula sheet. So the answer becomes a to the, so what is a in this problem is 7. So the function repeats itself, but I have to multiply by an extra ln of 7. So this is the derivative. Now I come back here. F prime of 0 becomes 7 to power 0 multiplied by ln of 7. But 7 to power 0 is 1, so it becomes ln of 7. If I ask you what is the geometrical meaning of ln of 7, you will tell me that number is the slope of the tangent line to the curve at this point. But the question is asking about the normal line. So what you have to do, so this means that the k value for the normal line is not this number, is minus 1 over that number. And then everything becomes clear. So you put them in the formula. So y minus f of a, which is e plus 1. This is the slope for the normal line. And then x minus a, which is 0. Usually we isolate y. So I multiply this in and move this package to the right. So what happens? This becomes minus 1 over ln of 7. And then I have x here, and then I move this to the right. So this is an equation for the line that passes through that point a0 and e plus 1 and is normal to the curve. Yes? Is that clear? So it might be a good idea if we also check this using GeoGebra to see it in front of our eyes. Okay, so what we are supposed to do, so first of all, if you don't mind, let us demonstrate the first problem, the problem that I don't know why this freezes. Okay, so do you remember the problem of drawing tangent line from a point outside the curve? So if you remember, the curve was y equals to x to the power of 2 plus 1. Yes? And now the point was the origin, so let me call it O, and the point is 0 and 0. I don't know, I think I should put equality between them. Yes, and then here. So that is my point here, you see. And I think there is a command here, so tangents, yes. So I can choose this tangent, and then I can click here, and then this one. And you can see that I have two tangent lines here. And if you remember from my solution, do you remember what was if you check your notes, my solution was the equations are y equals to 2x and y equals to minus 2x. And that these are exactly the equations. If you move minus 2x to the right, becomes y is equal to 2x. If you move y to the right, it becomes y equals to minus 2x. So that's exactly those things. And if you want to find the point of tangency using GeoGebra, probably what we can do, we can go probably here and then find the intersect point and then click on this curve and then this line. Okay, so this will give you the point of tangency, which you can confirm from my calculation it was 1 and 2, and I can click here and there and to find another point of tangency, which is minus 1 and 2. So that is the demonstration of that example, but that's also a good idea if we just get rid of all of them and then start doing this example. Yeah. So this example is this function y is equal to e. E is this number here, and then plus 7 to the x. So this is the curve that you see here. But what is the point? The x-coordinate should be 0. Of course, if the x-coordinate is 0, I already found that the y-coordinate is that one, yes? So let me just check another point. So the point is what? The x-coordinate is 0 and the y-coordinate is e plus 1, yes? Okay, so that is also on the graph. Okay, now I want to draw a perpendicular. So how can I don't think there is an instruction directly for the normal line. We do not have a normal to the curve, but we have the perpendicular line to a line. So what I can do, I can ask GeoGebra, for example, to draw the tangent line. So I go here, choose the tangent line, click here, and click there. So that's my tangent line. And then I can change this to perpendicular line, and I click on the line and the point. Okay, it worked like this. So this is the equation that we get here. Okay, but the equation we got there is the exact values. So we can calculate that that is exactly the same thing. So instead of doing that, let me just clean this. Let me take this off, and then let me just draw the graph. Okay, so my graph is what? Y is equal to minus 1 over, is there any ln? So let me see if ln, it doesn't work, I think. Let me see. Yes, there is ln, so it should work. Yeah, it doesn't matter. Let me clean this and use this. ln, and then it is 7, and then I go here, multiplied by x, and then I have plus e, and then plus 1, and that's exactly that line. So which angle is 90 degrees? The angle between this tangent line and this line is 90 degrees. So yes, so for example, I can choose some points here. I can choose a point here, and I can choose a point there. That's okay. Let me just choose the other point. So let me choose a point here and a point here, and then I can measure the angle, yes? So if I draw the angle, so you see that that angle is 90 degrees. So that's the meaning. So when this line is perpendicular to the tangent line, we also say that by definition that this line is perpendicular to the curve as well. Yes? Any questions? Okay. That's it for the time. There is a good problem in the book. I want to discuss about that. So let me show the problem to you here. Okay, this problem. It's a level 3 problem, and I think it's a very good problem. It's completely related to what we talked today. So we want to show that the tangents to this curve that are drawn from this point are perpendicular to each other. So what does it mean? This point that you see here, this point, is this point. X coordinate is minus 1, the y coordinate is minus a quarter. And from this point, you can see that we can apparently draw two tangent lines to this curve, which is the graph of this function. The point of this exercise is to show that the tangent lines are perpendicular to one another. Okay? Is the problem clear? So it's exactly a very good example of what we discussed today. So let us try to solve this problem together. Okay? I would recommend you to start the problem yourself so that after I clean the board, we can discuss it together. Okay? Okay, so do you have, so what is the point? What is the goal of this problem? The goal of this problem, this is important to learn, okay? You want to prove that two lines are perpendicular. So how do you think about the problem? Because it is not good to start doing random calculations. You know that this is related to the tangent. Some students might start doing the derivative because they know somehow this should be related to the derivative. This is not good. You should have a strategy, then take your pen and start doing something. Yes?
I guess you could find the tangent to one of the lines and
Yeah.
the perpendicular line in that point.
Yeah.
And then you find the other tangent and see if those two are equal.
Yeah, that's one strategy, but I think it's a very long strategy. So that's what I'm saying. And if you want to show what is the goal, forget about the curve and everything. Your goal is to show two lines are perpendicular. This is the goal. Okay? And then for this, you have a recipe. What's that recipe? If I give you two lines and I ask you, are these two lines perpendicular or not in Math 2C, how do you answer that question? Yes?
You multiply their k values.
You find the k values, multiply them. So it means that you have a strategy. Your strategy is to know the k value for this and know the k value of that, and multiply them. So you really don't need to find the full equation, because the full equation is not important here. And what is important is I want to know the k values here. Okay, but how can I find the k values? Because this new lesson, this point which is given to me is not the point of tangency, it is this point outside. So I have to pretend that I know the point of tangency. Which point of tangency doesn't matter, don't make the problem complicated for yourself. So let us take this one t, for example. But this t is not this one, this t might be that one, yes? But I told you that you just give it a name, a. But what is the y coordinate? If I give the x coordinate a, the name a, what will be the y coordinate? Because the function is y, x is equal to x squared, the y coordinate becomes this. Yes? Okay, and then if I want to find the k value, what I have to do? So this point is supposed to be tangent. So it means that now I take the derivative, f of x is x squared, so its derivative becomes what? 2x. So what is the k value? The k value is f prime of a. I told you, pretend that you know this a. Yes? So this becomes what? 2a. So this is the k value of this one, 2a. But which k value? It depends. If you choose this point, it will give you the k value of this line. If you choose this point for a, you will get the k value of that line. Yeah, so that's my k value. But the bad point is that I don't have the number for that. I want to multiply the k values. Okay, so what should I do? I would say that, okay, the equation of this tangent line becomes y minus f of a, so this is this one, a squared, is 2a times x minus a. This is an equation for one of these tangent lines, but of course it is not complete because still I don't know a. But then how should I find a, today's lesson?
You put in the y and x values.
Yes, because this point is definitely on the tangent line, so the coordinates of this point should satisfy that equation. So it means that if I replace y with given y value and replace x with the x value, oh, sorry, this is a. And I solve this equation and I will find my a. Yes, so let us solve that equation. So I get rid of fractions first. So let me multiply everything by minus 4. This becomes positive 1. This becomes positive 4a squared. the other side becomes minus 8a times minus 1 minus 8. I multiplied everything by minus 4. So this becomes, I multiply this in, it becomes positive 8a squared. Then I move everything from the left to the right. 8a squared minus 4a squared becomes 4a squared. I already have 8a there. And then I move this to the other side. Did you expect to get a quadratic equation? Yes or no? Because by the picture we see how many tangents we have? 2. So we should have 2 values for a, because I will have 2 tangencies, point of tangencies. And a quadratic equation usually have 2 answers, unless the discriminant is negative or 0. Okay, and then if I solve these equations, what do I get? Let us solve that. A is equal to minus 8 plus or minus b squared, which is 64, and then minus 4 times this times that, which is plus 16, divided by 2 times this number, which is 8. Yes? I'm just solving this quadratic equation using ABC formula. This plays the role of the number A, this plays the role of the number B, and this is C. So I put them in the formula, I got these answers. So A is equal to what? Minus 8 plus or minus a square root of 80 divided by 8. Of course, a square root of 80 is a little bit unfortunate. We cannot simplify it that much, but let me simplify this as much as I can. So what is your opinion about how to simplify this? Square root of 80 is 16 times 5. Yes? Square root of 80 is the square root of 16 times 5. So I can write it as 4 square root of 5. Yes? So this becomes 4 square root of 5 divided by 8. And I simply divide that. So minus 8 by 8 is minus 1. 4 by 8 is 1/2. Okay, I cannot simplify it more than that. We have to live with it, yes? So I have 2 values. A1, let me call it. It's minus 1 plus square root of 5 divided by 2. If you don't mind, let me write it in this form, simpler. And the other number is A2, which is minus 1 minus square root of 5 over 2. So these are the numbers, yes? Okay, but now, what is the k value of this one? So k value number 1 is 2 times the a value, so it becomes 2 times a1. And k value number 2 is 2 times a2. Yes? And then, what was my goal? My goal was to show that these 2 lines are perpendicular. Now I have the slopes, so I multiply them. So it becomes 4 a1 times a2. And what is a1 is this number, what is a2 is that number. So let me put them here and do the calculation. Yes? But this calculation is not that hard because hopefully you detect the pattern. What the pattern is? It's a conjugate rule, yes? So the answer becomes 4, the first number to power 2, minus the second number to power 2. And then you can continue the calculation. So minus 1 to power 2 is 1, minus this number to power 2 is 5 over 4. And then you multiply 4 in, it becomes 4 minus 5. And 4 minus 5 is exactly what we expect. It's minus 1. So we multiplied and we realized that the product of these numbers is equal to minus 1. By the way, I could do it simpler, of course, I don't know. I'm sure that I talked about this at some point. I told you that if you want to find, if you have a quadratic equation, ax squared plus bx plus c equals to 0, assume that you have x1 and x2, two roots for this equation. If you go back and see the notes, at some point I proved for you that the sum of the roots is minus b over a, and the product of the roots is c over a. So if I knew that, I really don't need to do all these calculations. Why? Because instead of doing numerical calculation, I would do it algebraically. So I would say that K1 is 2A1, K2 is 2A2. I don't need to calculate anything here. When I multiply that K1, K2, I get 4A1, A2. But A1, A2 is the product of the roots of this equation, which according to this formula is C over A, which is minus 1 over 4. Minus 1 over 4 multiplied by 4, it's simply minus 1. So you don't need to do all those calculations if you know these formulas. By the way, I don't know, for some reason, in the Math 2C book, it is among the exercises, but these are important. I would consider them as theorems. Okay, any questions here? Is that understandable? So you see that the level of the questions are actually high. I mean, this question is a hard question, I would say, if you cannot analyze that. And in the national exam, you will have questions of this type. So you have to prepare yourself. And I accidentally saw another equation here in the problem. It's actually a good problem here. So this was from the national exam, even though they considered this as a level 3 problem in the book, but it is simpler than, might be, I don't know. Let us check. This is also, we can solve both of them. But I would recommend you first tell me how to solve this problem. So in this graph, you see that you have the graph of the function. We don't know anything about the function. We just see this blue curve as the graph. Using the information on the picture, we want to calculate the derivative of the function at the point x equals to a. So how can I solve that problem? So the only thing that is given to you is this angle, 37 degrees.
How is the k-value and angles related? No.
This is something that you really need to know, yes? This is very important, by the way. Okay, let me remind you, if you have forgotten. So a slope, if I have a line, this is my line. This is the positive direction of the x-axis. Let me see if I'm recording it properly. Yes. So this angle that your line makes with the positive x direction, if I call it theta, then the k value of this line is equal to tangent of theta. I have already discussed about why this is true. Let us skip that for the time being. But this is the picture I wanted to. But it's important, by the way. If your line is in this direction, don't take this your angle. Still, this is your angle. So you always go from the positive x direction to your line and then measure the angle. What that angle is, take the tangent, it gives you a number. That number is precisely the k value of your line. Yes? So this is actually related to this problem that you see here, but I want to wait for you to solve that problem, yes? Or at least tell me what to do now.
Do we have to calculate this?
Let me show the picture here. So you see, if I ask you what is the slope of this red line, am I allowed to say tangent of 37 degrees?
No.
No, because this angle is not the angle that I described here on the board. I need this angle. Yes?
So that is extremely simple. So by this angle, I have to be able somehow to find this angle, but that's extremely simple, isn't it? Because this angle is equal to this angle, yes? They are vertical angles, they are opposite angles. And this triangle is supposed to be a right angle triangle. So what is this angle anyway? 53. So this angle is 53. When this angle is 53, this angle is also 53. So what I calculate tangent of 53. Tangent of 53 is the slope of this red line on the one hand. On the other hand, this red line is tangent to the graph. Yes? So this becomes the derivative. Is that clear? So if I want to write something here, so we realize the k value from what I described on the board is tangent of 53 on the one hand. On the other hand, according to the general picture, k is also f prime of a. Yes? So k value is on the one hand this number, k value on the other hand is this number. So this means f prime of a that the problem is asking for is nothing except tangent of 53. So it's a level 3 problem, but without calculations at all, yes? And then you put this in your calculator, you get a number. That number is an approximation for the derivative of this function. Is that clear? Oh, that was unfortunate. I forgot to record the board. Anyway, yes. So you see it on the board. So on the one hand, k value is tangent of 53. On the other hand, k value is f prime of a. So these two numbers should be equal. So that is the precise value of what is demanded. They haven't mentioned to approximate it. So I don't know. You can keep it like this, or if you want to, you can put this in the calculator. So now, if you don't mind, let us think about this national exam problem here. Yes, please.
In the case that the tangent line is more than 90 degrees, the k value, that one.
Yes.
If it's more than 90 degrees, then are we still able to take tangent of that angle and get answer?
That's a good question, yes. But you haven't studied that. You will study it in the last chapter. So you are right. In principle, that's a very good question, because for the time being, we know tangent, sine, cosine for angles in a right angle triangle, so it should be between 0 and 90. But in the last chapter, we will extend this idea so that we include all possible angles. Yes, in that case. But that was a good question, thank you. Okay, so let us go back here. This is a very simple problem. I mean, do you consider this problem a level 3 problem? So the calculation was nothing. But of course, I mean, yes, I would consider a deep question because it's testing your knowledge about the concept. And that is, by the way, very important. Both of them are important, yes? Okay, so let us go back here and then see that how much you can solve that problem. That's National Exam 2005. Show that the derivative is always non-negative for all x if this is the function, and read the problem carefully. A and b are positive constants. It's also one extremely simple problem. Just try to, it's a matter of seconds, by the way. It's not a level 3 problem that much. Oh, yes, I also think that this is simple.
Yeah. You just calculate the derivative like normal and you see that it's positive.
Yeah, exactly. So isn't it? So because what's the function? The function f of x is equal to what? A what? X to the power of 5 plus b x to power 3. It is mentioned that a and b are positive in the problem itself. We want to show that the derivative for all choices of x is positive or non-negatives, not positive. We want to show that, this is the question mark, we want to show that for all x, this means for all, we want to show that for all x, the derivative is positive or at least equal to 0. So that's the question. But that's simple, yes, because if I take just to take the derivative, this is a constant, 5 goes down, so it becomes 5ax to the power of 4. And then this 3 goes down, it is 3bx to the power of 2. But this is very simple now, do you see that? Because x to the power of 4, this part is greater than or equal to 0. Why? Because the power is even. This I can see, which is positive. This is also mentioned to be positive. So this product is at least 0. It's always positive. In some special case, it might be 0. And the same analysis here, yes, because this is also non-negative. This is mentioned to be positive. This I can see it is positive. So this number is also non-negative. I have a non-negative number added to another non-negative number. So definitely this number is positive, or at least it is 0. Yes. You need to write this in words, of course. Yes.
Okay, yeah, I was just going to ask how we're supposed to answer this.
Yeah, you have to write it in words. Might be
Okay,
this is
with
why.
sentences.
So yeah, you have to write what I said in words. Yes. Okay, so that is also one problem. Okay, so I think there was, if you remember, there was a problem that I wrote from an Indian book last time. So I was trying to solve that myself. Then I get stuck. Then I checked the solution. I realized there was a typo there. Okay, so in the book. So because when I was writing, I had this feeling something doesn't make sense. But because it was mentioned that is a level 4 problem in according to the Indian standards, I was thinking that, okay, this is extremely hard, that I cannot immediately see that. But do you remember what was do you have it?
Which one?
The first one. The second one is correct. By the way, the second one, I solved it very simple. But when I saw the solution of the authors, it was extremely hard. So they actually solved it in a very not efficient way. Okay, I could do it better than them. But this one, let me just fix it if you want to work on it at least. So do you remember it was log of 1 plus 4x or something? Yes.
It was log squared.
Yes, that's exactly. And then the typo was exact. That was a little bit. I was suspicious. So that was the other one was what?
A log base 2.
Yeah, that is not base 2. This is also power 2. Yes, and then can you write this one? Can you tell me here what is
1
the
minus 4 over
x plus 4 equals to what? 2 log to the power of 2 again.
brackets
Yes.
over x minus 1.
May you repeat, please?
2 over x minus 1.
2 over x minus 1.
Minus 1.
Minus 1. Yes. Now that the typo. So that was not my fault. I double checked that. It's still in the book. The 2 is here. But when you go and see the solution, the author put the 2 there. Okay?
What does it mean, log to the power of 2?
That is it. That is it. So for example, log of 2 to this one. So this one. It means you calculate log of 5. It becomes a number. Whatever that number is, you raise it to power 2. Yeah. That question, it's a good question, but then when I put this 2, then it becomes simple. And when I was just writing it, I felt that something is going to be wrong, you know. Yeah. But anyway, if you want to work on that, that was the problem we had. And the other problem was what? Log of x to the base y minus log of y to the base x is equal to 8 over 3, if I right?
Yes.
And then xy is 16. This problem, when I saw the solution of the author, it is not efficient to do it that way. It's nearly half a page. Yes? Might be that's the reason they thought this is a level 4 problem. But you remember I talked about this before. What is the relation between these two? We had this in Math 2C. This is one of the formulas which was not in the book, but I talked about that to you. Yes?
We can write it as plus, but we need to change.
No. Log, there is a very interesting thing for log. Log a to the base b is 1 over log b to the base a.
Yeah, that's what it says.
And for some reason, they haven't used this idea. They haven't used a very hard idea. But this is very simple. If you use this formula that I mentioned for this one, this is actually very simple, but that's also still a good question if you want to think about. If you're interested, we can talk about this tomorrow. Okay, there is one small part of this left, so I will talk about this, and that is how derivative tells me something about the rate of change of a quantity. So we want to talk about that one as well, and then the whole package will be finished. And then soon after you come back from the holidays, we need to have an exam. Okay, so let me pause recording.